questions. Here, we need to find how many functions are possible from A to B when the size of the A is given as M and size of the B is given as N. A and B both are finite sets. There will be at least one element in that. It's non-empty sets, both are, and the size is given as M and N, therefore it's a finite set. The last element of the A is mth element, last element of B is nth element. We need to find how many functions are possible in this. With the definitions, basic definition of the functions, we will be able to find out what is the count or how many functions are possible from A to B. We know that this kind of relation or mapping is allowed in functions, not this kind of relation. So, with this first kind, I'll try to explain here with the general statement. So let us define what is A. A, there are m number of elements. So let me call it as A1, A2, etc. M. The last element is AM. Take B element also, B1, B2, and so on, Bn. There are n number of elements in set B. So if I define a function f, then the first category, these kind of relations I can define. So with this, I will start with the mapping. If I take A1, okay, A1 cannot have all these as images, right? As per this. But all these elements can have a image B1. So with this symbol, all these can be paired with B1. So A1 with B1, A2 with B1, A3 with B1, and so on, AM with B1. Similarly, it is applicable to all the elements n, right? So instead of writing B1 once, B2, B3, etc., I will call this as, say, X. Instead of B1, B2, B3, I will call this as fixed element X. That means all these elements can be paired with any one of this. That is one function. In the similar way, if I go to next element, all these can be paired with this. All this can be paired with next element. All this can be paired with nth element also. So that's why we have taken here x, x, x as a common. Okay. So all these are mapped with x. That is one function. And this satisfies for one element here. So here, there are how many choices totally is m number of choices. Okay, I will start writing it for the m number of pages are there, and when I take in place of x b1, how many possibilities are there is n choices are there. Similarly, if I go to next, the second combination, there are n number of choices again. There are n number of choices again, and so on, n number of choices. So totally how many are there? M number of factors are there. Therefore, it becomes n to the power of m. So n to the power of m is these many number of possible functions from A to B. That is the meaning of this. Since you are writing in general, you have to take in terms of m and n size only. So when you take this function, there are n number of choices. Okay, there are n number of b1s. Here I can place b1 once, b2 once, b3 once, and so on. So it becomes n choices for this location. Okay. So like that we have done here, and so therefore n choices into n choices, and this happens m number of times because a size is m. Can happen m number of times. Therefore n to the power of m. Okay, I hope you understood. With that, we are moving on to second sub question. Second is if there are 2187 functions from A to B, that is total value they have given. So what is the total value formula? There are totally n to the power of m number of functions in general. So we equate that to 2187 and mod b is given as 3 and you need to find mod a. With this, you can apply these values n to the power of m, sorry, as per the formula. There are 3 to the power of m, which is equal to 2187 because this value is here. Mod b is nothing but n actually, so n is 3. M we are trying to find here. So, to simplify this, obviously you should apply log. When you apply log for this, it becomes m is equal to log 2187 by log 3. So when you simplify this, approximately you get 7. Therefore, mod A is equal to m is equal to 7. This is the answer for the second sub question, mod A.